So expansion and contraction of liquids. Now liquids also expand the same way solids expand when heated, and they contract the same way solids also contract when cooled. Now we have a demonstration that shows that liquids expand, and it will also tell us the relationship that is there between the expansion of solids and liquids. Which one expands faster? Now we have a diagram here. There's a round bottomed flask. Look at this round bottomed flask. Inside of the flask there's water, and then there's a tube at this point. Now that tube will gauge the level of the liquid when it expands and also when it contracts. Now what happens is the water is heated in a round bottomed flask. At first, the level in this tube, the level in the tube will be seen to drop. The level of water inside this tube will be seen to drop when heating starts. The reason why that happens is when you start heating, the heat energy does not reach the water immediately, but instead the flask expands faster because it is the one that will be heated first. It is the one that transfers the heat to the water. So the moment you start heating, or the moment the heating is started, the flask will expand. When the flask expands, it is going to create a bigger space. So the water level will drop to occupy that extra space that has been created within the flask. Then after some time, the level of the water will be seen to start rising. This level will rise because the heat energy has been conducted from the flask to the water. So the water starts getting that heat energy. At that particular point, we expect that it is going to be heated. Therefore, as a result of that heating, it expands. So as it expands, the level is seen to rise up. So liquids, most liquids expand faster compared to solids. And that case, the reason why the level of water will start rising notably is because the water will be expanding faster than the glass material used to make the flask. So that is a demonstration that liquids also expands. Number 2, liquids do not expand at the same rate. There are some liquids that expand faster, others expand at a slower rate. Now the expansion in a liquid depends on the density of that liquid. That depends on the density of that liquid. Now let's look at an example here. We have 3 liquids here. We have methylated spirit, we have alcohol, and we have water. These 3 are placed in round bottomed flask. They have a tube that is going to gauge their expansion, and then they are put inside cold water in a basin. This cold water is going to be heated, or is going to be replaced by warm water. Now when you put them in cold water, there's going to be a contraction. So the contraction level will be indicated by the levels of each of these liquids within the tubes, and we will observe that methylated spirit will have the lowest level here. Methylated spirit is the one that will have the lowest level, followed by alcohol, and finally the one that will have the highest level is water. So what does that tell us? We can conclude from there that methylated spirit contracts more than alcohol, which contracts more than water. So out of these 3, the one with the most contraction is the methylated spirit. So it contracts and it occupies a very small volume. That is why the level within the tube, when you talk about the methylated spirit, will be the lowest. The level inside the tube, when you talk about water, will be the highest. Because of these 3, water is the one that contracts the least. So we can relate these to their densities. Methylated spirit is very light. If you take methylated spirit and you pour on your hand, there's that cooling effect it brings because it vaporizes very fast due to its density. Now in the second demonstration, the cold water has been replaced by warm water. So the cold water has been replaced by the hot water. Now, in that case, the liquids are expected now to expand. They will not contract, but now they will expand. And the level of expansion will be indicated by the levels in each of the tubes into which these liquids are put. Now, if we put them under the same hot water, it will be noticed that the level of methylated spirit will be the highest, followed by the level of alcohol, and finally the level of water once again will be the least. Now, what does that tell us? Methylated spirit expands more than alcohol, which also expands more than water. There's a relationship between expansion and contraction of different substances. A substance that is able to expand the most will also contract the most when subjected to low amounts of heat energy, or maybe when subjected to very low temperatures. We can tell this from the bimetallic strip. Brass, when the bimetallic strip is heated, the brass expands the most and becomes longer, so it ends up forming the outer curve. When again cooled, brass is the one that contracts the most. Therefore, it becomes shorter than iron and forms the inner curve. But one thing has to be done when you are carrying out the experiment we have right here. One thing has to be done. The hot water must be stirred continuously. The reason for stirring is to ensure that the temperature of the water in the bath is uniform. So we are not talking about a situation whereby one of these liquids is subjected to higher temperature or higher heating than the others. And that is the reason why we don't apply heat energy here directly, but instead we boil that water elsewhere, or we warm that water elsewhere, and then we simply transfer it to a bath. But during that process, you must ensure that stirring is done so that they get equal amounts of heat energy with them. So that is an indication. Those two experiments will show us that even if the liquids expand, they don't expand at the same rate. There are some liquids that expand faster than others. There are others that expand a bit at a very slow rate. So on that note, we have anomalous expansion of water. Water is the liquid that we've been talking about here. Now, the word anomalous means unusual. So water expands, yes, or water contracts, yes, but there is an unusual way with which water expands or with which water contracts. So this unusual behavior of water is what is called the anomalous expansion of water. There's a certain temperature that when water reaches, it behaves abnormally. When you start heating water, it should be expanding, but it reaches a point, you're still continuing with the heating, but instead of the water expanding, it starts contracting. And the same applies. When you're cooling water from a given temperature, it will be contracting, but it reaches the same temperature where it behaved abnormally when heating, it again start expanding as you continue doing what? Cooling. This abnormal behavior of water is called the anomalous expansion of water. So that's what we will discuss in the next class. But for now, let's know the differences or the expansivity rates of different liquids as discussed above.